G'day guys, how's it going? So in this video, we're going to talk about logical operators in Rust and how they work. So up to this point, we've been using basic operators like arithmetic and things like that, just to add some numbers. But obviously, decision making is going to eventually be a part of what we do as programmers. So we're going to be working with Boolean values. And in the case of Rust, it's also considered Boolean expressions. So I explained in the previous video what an expression is. It's basically just something that returns a singular result. A Boolean expression is just an expression that returns a bool or a Boolean, right? So when we talk about logical operators, we're actually combining two Boolean expressions together to create, or two or more actually, to create an ultimate Boolean expression. It's a little cryptic the way I'm saying it right now, but it'll make sense when you see an example. So let's just jump into it. So let's say under a certain circumstance, I'm a human being and I want to ride a ride, say, at Disneyland, right? Generally, the rule of thumb is that you either have to be a certain height or you've got to be a certain age, right? So that's two different sets of criteria, and you have to compare the two together to find out whether you are actually allowed on the ride. So, for example, if I say let is allowed on ride, right, it would be based on, basically, am I tall enough or am I old enough? Oops, spell it right. So basically, this is an expression like, am I tall enough? How do I measure that? Well, in real life, we just measure that by using a ruler or something like a tape measure or something like that. And then, am I old enough? Well, that comes from your ID, right? They check your ID, find out what your age is, and then basically that will be the true or false, and this will be true or false, right? But the overall outcome will indicate true or false. Am I actually allowed on the ride? Yes or no, right? So that's essentially what we're looking at when we're talking about logical operators. Cool. So I'm just going to get rid of that. That's actually not Rust language. That's just what we call pseudocode. But hopefully you get the idea from that. So let's say, for example, and we'll do it for real this time. I'm going to have two values of true and true, right? And in this situation, I want to OR these together, right? So what an OR essentially is, based on what we just saw, it's one or the other. As long as you have one of those, you can do the thing on the left, right? So basically, in this situation, because they're both true, then the overall outcome will be true. Now, in Rust, to represent an OR, we don't type the word OR, we just type a singular pipe like so, right? And this is what we call the logical OR operator. Cool. Now, I don't know how many people who are watching know their Boolean algebra, but we have something called a truth table when we're using these logical operators. And basically, there's four different outcomes, right? There's true or true, true or false, false or true, and then false or false, right? So I'm just going to quickly copy and paste all the results, right? So what we're saying here is if it's true or true, then one of them is true, therefore the outcome's true. The first one's false, but the second one is true. Therefore, we still get true because one of them is true. Flip side for the third one. And then for the last one, we have false or false, which gives us an overall value of false. Cool. So let's just quickly run that just to confirm that that's actually true, which is kind of ironic that I said that. But there it is. True or true is true. False or true is true. True or false is true. False or false is false. Cool. So that is the first logical operator. It's the OR operator. Cool. Remember, it's a pipe. All right. So the next one is what we call the logical AND. And in this situation, it's similar to the OR, except that now we have to have both sides equal true. So think of something like, say you have to get on something and it only has a certain weight limit, right? So it could be that you have to be an adult and you have to weigh under, or most people that watch this will probably think kg, but let's say 80 kilos, right? Which I believe is 170 pounds or something like that in American metric. I'm not sure 100%, but you get the idea. You got to weigh under that weight in order to get on this boat, right? If you weigh more than that, then you're going to sink the boat, right? So think of it as they both have to be true in order for the result to be true. So in the case of what I got here, we got true and true, so that will be true. The second one, we have false and true. Well, that will be false because one side of it's false. Same with the next one, just flipped. And then false and false is obviously going to be false, right? So basically, the only time it's true is if it's true and true. So run that. Cool. And now we can see we get the exact results I expected. Cool. So that's the logical AND. Now we have what's called the logical exclusive OR. Now, this one's not used that commonly in most programming languages, let alone Rust, but it is available in Rust, so we have to talk about it. And essentially, it's using the caret symbol, right? So the caret symbol is what we use if we want to use an exclusive OR. Now, how this works, and I can't think of a practical example at the moment, but it's if the two values on the each side are the same, the overall result is false. If one of them is different, then the overall result is true. So in the case of what I got here, the first one, they're both the same, so the result will be false. This one, true and false on each side, so it'll be true, same as the next one. And then the last one is false, and they're both false, so therefore the overall will be false. Cool? So if I run that, we can confirm that. So basically, the first and last one are false, as expected, and the second and third are true. Cool. So that is a logical exclusive OR. Very rarely have I seen it used, but I just wanted to be complete. And then we have what's called the logical NOT operator. And that looks a little bit like this. So I'm just going to paste this in. So all it is it's an exclamation mark in front of the expression, right? So this could be another value or something. So I could have another variable here like let flag equals true. And instead of it saying not true, it could just say not flag, right? Same deal. It's going to take the value of flag and it's going to invert it, and therefore this would still be false, right? In fact, let's just run this and check it, right? So if I run it, you'll see that not true is equal to false and not false is equal to true. And that's pretty much it. Sometimes you want to check if the opposite is the case in a certain situation. So that's how you do that, okay? Now, they're the four logical operators. Basically, what we're going to talk about from this point onwards is how we can do different things, right? So, firstly, we'll just show more on how we can use variables. I kind of just showed it a second ago, but let's just do it again. So now I've got a variable, one's true and one's false. So the left is true, the right is false. And if I do the two here, this variable OR will be true because one of them is true, and this variable AND will be false because one of them is false, right? So let's quickly just run that just to show you that it works the same even with variables. And even if I decide to bring in conditional operators, all right, so let's just do that quickly. All right, so we've got some conditions now. I'll go through some of the examples here in a second, but essentially the first one is 1 double equals 1, so that's going to be true. 3 is less than 2, well, we know from the previous video that's going to be false. Then we can do basically, an OR between the first two. Then we can do an AND between the first two. So this would give true, this would give false. Then we can take that same condition and then use it again, right? So then this now becomes essentially, if you think about it, this becomes left condition, right? Or right condition. But see how that starts to get a little bit complicated, right? But that's essentially what we're doing when we're using this instead of this, right? We're just making it simpler on ourselves to understand. Well, I made a mistake there. To make it easy on ourselves to understand exactly what we're working with. Cool. So in that situation, it's going to factor in everything that comes before it. Cool. Same as the next one, it's going to do the same thing, right? It's going to evaluate everything that comes before it, including an and between the two. All right, so the conditional or will return true, but the conditional and will return a false. So this result will be false, right? And then what we've got is we can have more than two, right? We can have three, we can have four, we have five chained together like this, right? And in this situation, when you see a pipe and an ampersand together, the ampersand, the bit that's surrounding the ampersand, that will be evaluated first. Then the or will, right? So let's think about if we didn't do that and we looked at what was here. So conditional or is set to true, right? If I go or with another or, well, actually, these two are both true, right? Understand? However, if we go and after that, so we got true and false, this is going to return false, right? But let's run this and actually have a look at what actually gets returned. So it's the very last value, and you can see it says true, right? So it's a bit confusing if we say, okay, we go from left to right, and we say, okay, we're just going to do the ors first. That's an overall of true and false, so it should have been false, right? Well, no. Like I said, the ampersand has precedence. We call it precedence over the or, right? So now if we think about it, this is true and this is false, right? So this overall here is false, right? But this is true. So because now we're talking about one of them being true only, this, because it's true, will now spit out the value of true, which is why we get that, okay? So just be very mindful when you start messing around with multiple ampersands and multiple ors and ands, I should say. Just be mindful that ampersands, i.e. ands, get evaluated first. Cool. So up to this point, we've just been looking at the single pipe and the single ampersand operator, which is one way of doing logical ands and logical ors, but there's actually another way. And it's basically what we call the short circuit way of doing it. So let me show you an example at the moment, right? So I'm going to just paste in some code here and I'm going to explain it. So this variable here is the result of a true or what we call a block, right? Now, I haven't got into what blocks are yet, but ultimately just look at the fact that there's a true at the end of this block. So it's true or true. That's essentially what this is going to do, right? Now, that's going to lead to this being true. And so when I print it out at the bottom, it's going to return true, right? In fact, we can check that in a second. But what I've done in this block is I've actually added a print statement. And the reason why I'm adding a print statement here is because I want to show you that no matter whether I got true immediately, it's still going to execute the right part. So normally you would think in a situation where the first value is true in an or, well, what's the point of evaluating the second part when we've already got the first part is equal to true, right? Why do that at all? We might as well just go, okay, we got true immediately. We just set it to true, right? However, what we're going to find is when we run this, it actually will execute the right side as well, right? And that's because we're using this single pipe, right? This is considered an unlazy or expression, but in a lot of situations, all we really want to do is have a lazy or, right? i.e., we want to just detect if the first side's true, then don't worry about the right. And now we can do that by just adding a secondary pipe, right? So if I now save this and run it again, for example, now you're going to see that print statement wasn't fired. And that's because the right-hand side of this double pipe expression or double pipe operator was not fired. This was never executed. Only this was, right? If I change this to false, right, i.e. we didn't get a true immediately, what you're going to see now, even with the double pipe, is that the right-hand side was still executed. Cool, because it had to be, because the left-hand side didn't qualify to be true, right? So that's what we call short circuiting. And for the most part, this is the way I do OR expressions in Rust. All right, but I wanted to show you the first way first, just because that's the way that I learnt first. But then obviously, as I go along, I learnt more and I understood short circuiting in Rust. So this is the approach I take going forward, and it will be the approach I take going forward. Cool. So let's just quickly do another example with an AND. So I'm going to do the same thing. I'm just going to paste this in and print it out. And in this situation, the first value is false. And because I'm using the double AND, all right, so once again, I'll go to a single AND for a second. If I run this, it's going to execute both, right? Even though this is false, and it should return immediately, it will execute the second part. Cool. But if I add the second ampersand, i.e. now we're going to short circuit the expression. If I run this, now, oh, I'm not sure what happened there. It's interesting. Let me try running it again. There it is. Okay. So now it's printed out false, right? Straight away. And it never printed this line here. Cool. So that's short circuiting. You can obviously mess around and try other ways of doing it, adding some extra ampersands and ors and see what happens yourself. And I do recommend you try that. But for me, I'm going to end the video here because this is pretty much all you needed to know. So thank you for watching, and I'll see you all in the next video.